To perform the Mann Whitney U-test using SPSS, first you need to define your variables. Do this by clicking on the Variable View tab at the bottom of the screen. Then you will type the name of your variables in the name column. Unlike the Wilcoxon signed ranks test, you cannot simply enter each sample into a separate column to execute the Mann Whitney U-test. You must use a grouping variable. The first variable is the grouping variable, which we will call method. The second variable we will call score, and consists of our actual values. When establishing a grouping variable, it is often easiest to assign each group a whole number value. We do this in the values section. So our first method will have a value of 1. The label will be method 1, and then click add. Our second method will have the value of 2. We will label it method 2 and click add, then click OK. Make sure that the measures are correct. Since method is a grouping variable, we will label this as nominal, and our scores are scale level data. Next, enter in your data values. Next, we're going to analyze the data. Select Analyze, Non-Parametric Tests, Legacy Dialogues, 2 Independent Samples. You'll see this box. The variable we are testing is the score, so we'll use the arrow to put that in the test variable list. And our grouping variable is method. Again, use the arrows to put this in the grouping variable box. We also need to define our groups. Group 1, we use the number 1, and for group 2, we use the number 2. And then hit continue. We're doing a Mann Whitney U-test, so check the box next to that and click OK. The first SPSS output table provides the sum of ranks and sample sizes for comparing the two groups. The second SPSS output table provides the Mann Whitney U-test statistic, which in this case is 7. It also returns a similar non-parametric statistic called the Wilcoxon W-test statistic. In this case, W equals 35. Notice that the Wilcoxon W is the smaller of the two rank sums in the above table. SPSS returns the critical z-score for large samples. In addition, SPSS calculates the two-tailed significance using 2 methods. The asymptotic significance is more appropriate with large samples. However, the exact significance is more appropriate with small samples or very poorly distributed data. Based on the results from SPSS, the ranked reading comprehension test scores of the 2 different methods were significantly different. U equals 7, N for sample 1 is 7, and N for sample 2 is 7, and the p-value is less than 0.05. The sum of ranks for method 1, which is 70, was larger than the sum of the ranks for method 2 of 35. So we can say that method 1 had a larger impact in reading comprehension. Remember that using SPSS, we will always have a two-tailed significance. If you were to need a one-tailed significance, simply divide the p-value provided by SPSS by 2.